Tonight's lesson is 1-3B, Composite Functions. Composite functions are when you plug one function into another function. We're going to start off with one where we're going to be dealing with a number as the output, because our final spot here is a number. You know you're going to have a number for an output whenever you have a number in the parenthesis at the end. If there's a variable there, you're going to have a variable for an output or an expression or a quote for the output. So this composite function is f of g of x, or f of g of -4, excuse me. And what that means is we are going to take the g function and bring it into the f function and come up with a separate equation. So another way this can be written is f of g of, and I'm just changing colors to kind of help us see what's happening as we're going through these steps, of -4. And the best way to do this is take it one step at a time. So we're first going to find what g of -4 is. And so I'm going to come over here to the side and use this to help show the work for g of -4. So we know that g of x is equal to 2x squared plus 5. So that means that our rule is 2 times what we're plugging in squared plus 5. And what we're plugging in this case is that -4. So 2 times -4 squared plus 5. And I'm just going to kind of show you a little bit of the work over here on the side. 2 times -4 squared is 16. It's a positive 16 because a negative times a negative is a positive. 2 times 16 is 32. And then we're going to add 5 to it. And that gives us our output of that 37. Oops, 37. So that is going to replace what I've highlighted in yellow over here. So we now have f of 37, because we first had to find what g of -4 was. That's the first step of this f of g of -4. We have to find what g of -4 is before we can plug that into the f function. So what we're plugging into f is that g of -4, which we found to be 37. So that is going into that f function that we found that was given to us as 3x minus 1. Excuse me. 3 times what we're plugging in minus 1. So the number we're plugging in is that 37 So we have 3 times 37 minus 1 and so 37 minus 3 times 37 is 111. So we have 111 minus 1 or 110. Now, there's no place else for me to plug that in, so that's our final answer. So again, the process, when you're dealing with a composite function, is you start on the back and you work your way forward. So you're working this way on that composite function. You take the thing at the end, the last parenthesis, and you're going to plug into the function right before it, and you're going to take that answer and plug it into the function in front of that. Now, here's another example of a composite function. So this one's already written in that second format, where we have g of f of x. The letters don't have to be in any certain order here, but they tell us the order we're going to solve it for. So this time we're going to plug the f function into the g function. But if you look here, that's a variable. So that means we're not coming up with a numeric answer of a 5, a 6, a 7. Although sometimes that can happen, typically we're going to come up with an equation. So let's start at one piece at a time. So we need to figure out, what are we going to plug into that g function? Well, we're going to plug into that g function what f of x is. So f of x is 2x minus 5. And so our input is 2x minus 5. And remember that we said that this is a placeholder, that the f of x, or in this case g of x function, which is what we're solving for in here, when we're using this input, we're having a placeholder that's 3x plus 4. This x is a placeholder. So we have 3 of something plus 4. So in this case, that's 3 of our 2x minus 5. So we're going to have to use our distributive property to help us solve this, and I am just going to show the scratch work right below it. So we are going to distribute that 3 through the parenthesis. It is not going all the way over to the 4 because the 4 is not in the parenthesis with it. So it's 3 times 2x, 6x, 3 times negative 5, 15, plus 4. Combining our last two numbers, be careful in this. We have to take the sign in front of the 15. The 15 is minus, so that counts as a subtraction. Negative 15 plus 4 is negative 11. So our answer is 6x minus 11. So that's your output. And so I have found what my f of x function is, plugged it into the parenthesis, and then taken that information and use my little function notation over here. Help me plug it into, or my function machine, help me plug it in. And so g of 2x minus 5 is the same thing as 6x minus 11. So this is my answer.